So we need to use the definition of a Taylor or Maclaurin series to find the first four non-zero terms of the Taylor series for the given function centered at A. We also need to write the power series using summation notation and determine the interval of convergence of the series. So if A equals 0, then the series is called Maclaurin series. So this is Maclaurin series. And the Maclaurin series has a form f of x equals the sum from n equals 0 to infinity of f of the nth order derivative of f of 0 times x to the power of n over n factorial. So in our case, the series expansion is f of x equals f of 0 plus f prime of 0 times x plus the second order derivative of f of 0 times x squared over 2 factorial. Wait, let me move this a little bit. Plus the third order derivative of f of 0 times x cubed over 3 factorial, and so on. So now we need to calculate the derivatives. F prime of x equals the derivative of e to the power of 2x with respect to x. So it's 2 times e to the power of 2x. The second order derivative of f of x equals 2 squared times e to the power of 2x. The third order derivative of f of x equals 2 cubed times e to the power of 2x. And the fourth order derivative of x equals of f of x equals 2 to the fourth power times e to the power of 2x. Now let's find it at x equals 0. So f of 0 equals 1, f prime of 0 equals 2, the second order derivative of f of 0 equals 2 squared, the third order derivative of f of 0 equals 2 cubed, and the fourth order derivative of f of 0 equals 2 to the fourth power. So that means that the Maclaurin expansion for the given function is e to the power of 2x equals 1 plus 2x plus 2 squared times x squared over 2 factorial plus 2 cubed times x cubed over 3 factorial plus 2 to the fourth power times x to the fourth power over 4 factorial, and so on. So the first four non-zero terms are the first term, let's call it b1 equals 1, the second term b2 equals 2x, the third term b3 equals 2x squared, and the fourth term b4 equals 4x cubed over 3. Well, now we need to do part B. We need to write the power series using summation notation. So from part A, where we have found the series expansion, we can get the power series in summation notation as e to the power of 2x equals the sum from n equals 0 to infinity of 2 to the power of n times x to the power of n over n factorial. And finally, we need to determine the interval of convergence of the series. We will use the ratio test. So L equals the limit of the absolute value of an plus 1 over an, where n approaches infinity, so it equals the limit of 2 to the power of n plus 1 over n plus 1 factorial times x to the power of n plus 1 over 2 to the power of n over n factorial times x to the power of n approaches infinity. Then this equals the limit of the absolute value 2 to the power of n plus 1 times x to the power of n plus 1 over n plus 1 times n factorial times n factorial over 2 to the power of n x to the power of n. And this equals the limit of 2x over n plus 1 where n approaches infinity, so it equals 2 times the absolute value of x times limit of 1 over n plus 1 where n approaches infinity, so this equals 0. Since 0 is less than 1, the series converges for all x. This for all x. So that means that the interval of convergence is from negative infinity to infinity. So the interval of convergence is from negative